Morning, guys. How are you? Sure. So this week we are still on Unit 2. This week we'll be writing on Module 2.3 loops and Module 2.4 Boolean algebra and computer logic. If you go to 2.3, as always, you have your open book quizzes and the material at the top. 2.3.1. Go ahead and open that. And 2.4.1, you also have the open book quizzes there. Go ahead. Okay, 2.3 is about loops. We did cover loops in Unit 1, but we did not go deep into it. You still remember. Okay, we're going to start with this example. It's just a small program that determines the largest number of any given numbers. In this example, first they used an if statement. If you want to find the largest number of two numbers, it is easier to use an if statement. If we can go through this, there we declare our numbers. Then Cin, we get our two numbers. Then we assign the first number as the maximum, in our case the largest. And then we use an if statement to check if the number 2. Remember here we say the largest is number 1. Then we use an if statement to check if number 2 is greater than number 1, the maximum. If that is true, then the maximum now becomes the second number 2. But if that is false, then number 1 remains the largest number of the two. And if you want to find the largest number of 3 numbers now, it's the same. You can use the same method, and you can still use an if statement. You can see there you're getting 3 numbers from the user. We set the maximum as number 1. Then an if statement, if number 2 is greater than the maximum, in this case now it's number 1, then number 2 will be the largest. But if number 3 is greater than the maximum, then number 3 will be the largest. Then we can print out the largest number of the 3. But what if now we want to find the largest of 100 numbers? You see, if we continue using an if statement, it's going to be a very long code. Do you see that? So we need to use a loop. So there's an example here of an algorithm for a loop. An algorithm is a pseudocode, which is step by step of how you want your program to run. So this is a pseudocode for finding a maximum of any number of numbers that you can give to the computer. And if you enter a value of -1, then you tell the compiler to stop, that program to stop, and immediately give you the largest number of all the values that you have been entering. So if you look at this pseudocode, we set the maximum to negative 199 million. Then we read the number. Reading the number is getting those numbers, the number from the user. If that number is equals to -1, the program stops. It prints out the maximum value from all the numbers, and then it stops. But if it's not -1, you're going to skip that. If it's not -1, we check if it's greater than the maximum number, which is at first it's negative 999. If it's greater than that, then it will become the largest value. Then we go back to number 2. Then it will loop to there until that condition is true. Do you have questions on that? No. The first loop we are going to look at is the while loop. This is the syntax for a while loop. So if from this example they say while my hands are dirty. So as long as your hands are dirty, you're going to wash them. So that is while your hands are dirty, you wash them. But if they are no longer dirty, then that condition is false. Then you're going to stop washing them. That is breaking out of the while loop. This is the syntax. You have your keyword while, then your test expression, and then your statement that is executed if that test expression is true. If we have more than one statement in the body of our while loop, we put those statements in a block. You still remember that. And we must be careful when using the while loop, because sometimes that while loop can enter what is called an infinite loop. If you look at this, while it's true, then print out that message. But since there is nothing that is changing that value of the test expression, that condition will always be true, and your program will continue printing that infinitely. So if your hands are always dirty and they're not getting clean, so you see that you'll be washing your hands for the rest of your life, stuck in that sink, because that condition is not changing. So make sure that in the body of your while loop, there should be an expression that is changing the value of your condition. And if you remember, we can declare values and declare variables and give them a value at the same time. In this example, we know int is the type, then variable, that is the identifier, that is the assignment operator, and that 0 is an initiator. And we always end declarations with a semicolon. So this is still an example of finding the largest number of any given numbers, but now we did not use. But now we're using a while loop to check if that value is -1 or not. Remember, we said if you enter -1, then it should stop and give you the maximum value of all the numbers that you've been entering. So if we can start from the top, then we declare our number. Cin, we enter the number, and that number, if it's alone, then it's the largest. It will be the largest. That's the maximum. So while that number is not -1, when we go inside that while loop, we check if that number is greater than the maximum. If it is, then it becomes the new maximum, new largest number. Then we prompt for a new value, for a new number, until that is -1. Then it will give us the maximum of all the numbers, and then we finish. So, do you have questions here? So the following is an example of a program that counts the number of even numbers and odd numbers that is given to it. So at first, with no number entered to this program, the number of even numbers will be 0 and the number of odd numbers will be 0. That is the number that we enter to the program that is prompting for the user to enter a number. So while that number is not 0, if that is true, we go inside the body of the loop. If we divide that number by 2 and the remainder is 1, is that an odd number or an even number? It's an odd number. Then we increment the number of odd numbers. But if that is not true, we increment the number of even numbers. Then we print out the number of even numbers and the number of odd numbers. And this is an example of a while loop that prints out the statement a number of times. How many times do you think that statement will be printed out? Our counter at first is 5. So is 5 equals to 0? It's not equals to 0, then it will print out, and then we subtract 1 from 5 until 5 is 0. So that will be printed out 5 times. So there's different ways of writing this same program. So your while counter is true, print out that, subtract 1, and there's also another one. While counter is true, you check the condition and subtract at the same time. It's the same program. It will print out I am an awesome program 5 times. Then we have what is called a do-while loop. With the while loop checks the condition first before it goes into the body of the loop. But the do-while loop, it will always execute the body of the loop first, at least once. Then it checks the condition. Do you see the difference there? So those statements will be executed first, and then the condition is checked. If that condition is true, then it goes back to then it loops again, but if then now it's false, then it break out of the loop. Then we have the for loop, which has three parts, which is the initiator, then checking of the condition, and the modification of the count. That is the syntax of a for loop. We initialize first, then we check our condition, then we execute anything, instructions inside the body, then we modify our counter. There's an example here. We initialize I as 0, then we check if I is less than 100. Then we do whatever is in the body. But once I is no longer less than 100, then we break out of that loop.
Why is it when you initialize 0, you don't use double equal sign?
When we initialize 0, double equal sign is for checking.
Okay.
For checking if it's an equality operator. You are checking if this value is equals to this one. A single equal sign is just assigning a value to a variable. Good. So if you write a for loop like this without all these elements, it will become an infinite loop. We saw the version of a while loop that will execute infinitely. Even with a for loop, if you write a for loop like that, it will enter an infinite loop. And this is an example of finding the power of 2 with different exponents. We use the for loop. First, our initial exponent is 0. What is if you look at 2 to the exponent 0 it's 1. Then we check if our exponent is less than 16. 1 is still less than 16. Then we give you the exponent of the result of 2 to the exponent 2. 2 to the exponent 0. Then we update our exponent to 2 up until 15. Then it will give you the results for 2 to the power 0, 2 to the power 1, 2 to the power 3 up until 15. This is an example of how we use the do-while loop to check the number, the largest value of any numbers that we put into that program. I think that's one you can practice on your own and see how it works. We'll go to 2.4.1, computers and their logic. You know, logic operators like AND, NOT, and OR. So this is what we're going to be looking at now, and how those logical operators work. So we have a an example here with this statement. If we have some time, some free time, and the weather is good, we'll go for a walk. So if you see here, both these statements need to be true in order for us to go for a walk. So this is how an AND operator works, or a conjunction operator. We will see that later. So if we don't have free time, we cannot, regardless of whether we have the weather is good or not, but if we don't have free time, then it is not possible for us to go for a walk. We can have the time, but if the weather is not good, then we cannot go for a walk. So if you see those, the two conditions need to be true for us to go for a walk. And the or the conjunction operator. So if you are in the mall, or I am in the mall, one of us will buy a gift for mom. So in this case, only one condition needs to be true in order for one of us to buy a gift. It's either we can both be in the mall, we can still buy a gift. You can be in the mall alone, you can still buy a gift. I can be in the mall alone, I can still buy a gift. But if we are both not in the mall, then we cannot do that. Do you see the difference there? So that is how we write the conjunction operator, the two ampersand signs. That is the truth table for a conjunction operator. If you look at that example from the first example, like if the weather is not good and we don't have free time, then we cannot go for a walk. And true and false will result in a false. False and true will result in a false, but true and true will be a true. And that's the symbol for a disjunction operator, the two bar signs. If you remember, said only one condition needs to be true for us to get a result of true. But if both are false, then that will be a false. The logical negation operator, which simply changes a 0 to a 1, and a 1 to a 0. So a false will be a true, and a true will be a false. And we use the exclamation mark for the symbol of the logical negation operator. That is the same as that, and that is the same as that. The Boolean operator, you still remember what the Boolean operator is. It only has two states. It's either it's true or false. So we've been looking at logical operators. So now we're going to look at bitwise operators. So bitwise operators allow us to work on single bits of a value. And these are the operators we have, conjunction operators. If you see, it's just only the ampersand sign. Now it's only one. And the disjunction operator, it's only one bar sign. The negation operator, it's not a exclamation mark anymore, but it's the tilde. Then the exclusive OR operator, which is that sign. The bitwise conjunction operator needs exactly 2 ones to result in to provide an answer of 1, to provide a true. And the bitwise conjunction disjunction operator need at least 1 true condition to give us a true. And the exclusive OR operator needs exactly one true condition to give us a result of true or 1. And those are the true tables for all those operators. So this is here it's an example of logical operators and bitwise operators. We said bitwise operators, we deal with the single bits of that of their values. The first example here is the logical operators. So we declared here I as 15 and j as 22. That is the binary value of 15. That's the binary value of 22. So if we say I and j with the logical conjunction operator, those values 15 and 22, as long as they are not 0, but they are any other number, they are regarded as true. If it's a 0, then it will be a false. And that I and I, which is true and true, will result in a true. But with bitwise operators, we work on the single bit of the different variables, of the different values. So if you look at here, I and j, what will be 1 and 0? We say the conjunction operator needs exactly 2 to provide a true, a 1. So 1 and 0 will be a 0. So, and 1 and 1 will be a 1. Then again 1 and 1 will be a 1. 1 and 0 will be a 0. 0 and 1 will be a 0. And the rest will be zeros. That is the answer there. And that is just a different way of writing that. You can look at that when you're preparing for your test. Then we have this flag register. So let's say you are given that value, and you are only allowed to modify that bit, that fourth bit there, which is marked as X. So there's different scenarios that you can work around modifying that single bit that you are allowed to change. The first condition will be to check your state of your bit. Checking the state is we're checking if that value is 1 or 0, and we can already only compare it with 1, because if you compare it with 0, then it will just give you the value as it is. It will not show you it will not show you the state of that value. If it's do you get that? So if you want to check if X is 1 or 0, and we use the conjunction operator. If you want to check if it's a 1, then we check it with a 1. It will return a, if you say 1 and 1, if X is 1, 1 and 1, we return the state of X, which is 1. But if it's 0, if X is 0, if you say 1, 0 and 1, then you return a value of 0. Then you know what the state of your bit is. See. So the other scenario would be to reset that single bit. Resetting is, if it's a 0, it must stay a 0. If it's a 1, it must change to a 0. Resetting. Did you do that in digits, or remember that in digits? Resetting, you change that value. If it's a 0, it must stay a 0. If it's a 1, it must change to a 0. And then setting your bit, if it's a 1, it must stay a 1. And if it's a 0, it must change to a 1. And to negate your bit, that is simply if it's a, we said negation is if it's a true, it must change to a false, and if it's a false, it must change to what? If it's false, it must be true. And then shifting. Let me look for an example for shifting. So shifting values bitwise values, we use that operator. If you want to shift the bits to the right, and we use that to show the direction. If we shift the bits to the left by 2, if you look at here, it's a, if you shift the bit to the right by 1, it's equivalent to dividing it by 2. But if you shift it to the left by 1, that is equivalent to multiplying that value by 2. That is the updated list of priorities, or the table of priorities that you can also look at. That's the end of today. Do you have questions?